Good afternoon. Trig Identities Part 3. Here we go. I'm going to make the left side of this the way I want it. So I'm going to call this 1 over cosine of x plus, and I'm going to go ahead and make tangent of x sine x over cosine x. And let's just mess with the left side of this for a while. We'll leave the right side alone here. So that's going to become cosine x on bottom, and on top 1 plus sine x. Now we'll go ahead and bring the bottom down at this point. Cosine x over 1 minus sine x. And if I'm going too fast, just rewind it and watch this again. It'll all work out. Now at this point, one of the things that one of the little tools that you have available, and sometimes it's a really bad idea to do it, and sometimes it's a good idea to do it in this case, is this cross-multiplying thing. This idea of cross-multiplying in this fashion kind of makes things work out well when you do this, because if I cross-multiply in this direction here, okay, in that direction, I'm going to get cosine squared of x. Cosine squared of x. And if I multiply this way, what I'm going to get is the answer to a difference of two squares problem. So I'm basically going to get 1 plus sine x times 1 minus sine x. And what that's going to turn into after you FOIL that is 1 squared plus, or not plus, minus sine squared x, which is equal to just 1 minus sine squared x. And that's equal to cosine squared x. I just brought that down there. Well, this is the same thing, because based on the trig identity, sine squared x plus cosine squared x equals 1. That's what that is. If I bring that over, that's going to equal this right here. So they're both equal to each other. So you could just say cosine squared x equals cosine squared x. And put a big old happy face on that. So let's try the other one. That's a little bit more tough. I'm trying to do 2 for 1 here today in part 3. Is this right here. And this is a 4th power minus a 4th power. Now, something really interesting happens here. I just find this fascinating in a very geeky way. So this minus this is kind of like a difference of 2 4th powers. And it turns into that. And let me just move that over a little bit. This plus cosine squared x. Give myself a little bit more room there. Well, all of that is, of course, going to equal this, and I'll write that out in a minute. But this sine squared x plus cosine, that's 1. So that whole thing there is just 1. And 1 times this first thing is just that first thing. Sine squared x minus cosine squared x. And that equals 1 minus 2 cosine squared x. Well, now comes a tricky bit, because this is where you need to start thinking about terms like this as just a variable, as if this is, say, n, and this is 2n. And if I add n to both sides, I just get negative n over here, and that cancels. Well, let me back up and do that whole idea there with these things. I'm going to add to it cosine squared x to both sides, because here I have 2 of them, and here I'm adding to it 1 of them, and I have sine squared x equals 1 minus cosine squared x. And you can see, just like the last problem, in fact, that was, if you flip back, I bet you that was the exact same thing. Oh, no, it was the other way around, but similar. So this right over here is equal. This is equal to sine squared x. That right there is equal to that. And, of course, sine squared x equals sine squared x. You guys have a fantastic day. See you.